Greetings, I'm Squared here, and today we're going to talk about the Pythagorean Theorem. You should have learned this in 8th grade, maybe 7th, and then reviewed it in Algebra 1. But today we're going to go a little step higher. So we're going to review what you should already know, and then we're going to take it one step further, because this is geometry. So first of all, the Pythagorean Theorem says if it is a right triangle, then the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Well, what does that mean, the square? Well, if you had a little triangle, you can see the picture right here. If this was your right triangle and the sides were 3, 4, and 5, what it's saying is if you make a square, when it says you square it, you actually make a square with that length, that 3. So that would be a 3 by 3 square. The area would be 9. Or squaring it, 3 times 3 would be 9. And if you do that same thing to this side, it's 4 by 4, that gets you 16. And then to the hypotenuse, which was 5, 5 by 5 is 25. And 9 plus 16 is 25. So it's the squares of the legs that add up to the hypotenuse. So this is kind of a visual picture, because some people don't understand what's happening. The biggest mistake that people make is they don't remember that c squared has to be the hypotenuse. So make sure you know that the biggest side is always going to be the hypotenuse, and that's all by itself on one side of the equation. So here are a couple problems that we're going to do to find x. So you'll notice that here, x, I'm missing the hypotenuse, but over here I'm missing the leg. So I set it up a little bit different. So I'm going to say a squared, so that's one of my legs. And then b squared, that's my other leg, has to equal c squared. So I square each of them. Well, the square root of 17 squared is just 17. The square root of 5 squared is 25. And the square root of, I'm sorry, I said the square root. The 5 squared is 25. And then we have just x squared. Then we add these two together. So that's going to be 42. And if you're going to solve for x, you have to take the square root of both sides, and then you'd have to kind of figure out, are there any perfect things in there? That's 2 times 3 times 7, because 6 times 7 is 42. So there's nothing perfect in that. So that means x does indeed equal the square root of 42 in its simplest form. If you were asked to round, you could round it. It depends on the directions. So over here, since our legs are x and 12, I'm going to say x squared plus 12 squared, and that's going to be equal to 16 squared. So I'm going to actually square those. That's 144 and 256. Then I'm going to subtract 144 from both sides. And I get x squared equals 112. So then again, I'm going to see, hey, what goes into 112 evenly if I want to do this, get it in simplest radical form. I know that if the last two digits are a factor of 4, or a multiple of 4, then it's divisible by 4. And then 28 is divisible by 4, so now I know that's 16 times 7. Because if I divide it by 4 again, those are my two 4s, which is 4 times 4 is 16, and then 7. So when I take the square root of both sides, I know that I'm taking the square root of 16 and the square root of 7, and the square root of 16 is 4, but the square root of 7 isn't a perfect square. There's no perfect factor in it, so I know that the answer is 4 squared to 7. So that's the Pythagorean Theorem. That should be a review. However, I did it with square roots because we're kicking it up a notch, but you should have done that, like I said, in 8th grade. Now the converse of the Pythagorean Theorem says that if the sum of the squares of the shortest sides of a triangle is equal to the square of the longest side, then it's a right triangle. So we can also use it to prove that a triangle is right. So we want to know if this triangle is a right triangle. Then we would take the shortest sides. Those are 5 and 5, because 5 times square root of 2 is going to be bigger than 5. So I'm going to say 5 squared plus 5 squared. If it equals 5 squared to 2 squared, then I know it's a right triangle. So 5 squared is 25 plus 25. When I square this, remember that's 5 squared to 2 times 5 squared to 2. So it's 5 times 5, which is 25. And then square root of 2 times the square root of 2 is the square root of 4, which is just 2. 25 times 2 is 50. 25 plus 25 is 50, so it indeed is equal. So yes, that is a right triangle. Okay, let's try this one. The square root of 79 I know is 8 point something, because the square root of 81 would be 9. So I know that that's the longest side. So 5 squared plus 7 squared has to equal the square root of 79 squared. So that's 25 plus 49 has to equal 79. Remember again, when you square a square root, They cancel each other out. Those are opposite operations. So the square root of 79 squared is just 79. So when I add these up, I get 74. Does that equal 79? It does not. So this is not a right triangle. So those are the two ways you can use the Pythagorean theorem and the converse to find missing parts or to say whether it's right or not. But the cool thing is if you go now a step further, so you should have never learned this before, we can also use the Pythagorean theorem, sort of, to tell whether it's an acute triangle or an obtuse triangle. So right here, I can tell that this right here is going to be an obtuse triangle because c squared was actually bigger than a squared plus b squared. So we're going to talk about that. These are little formulas. So we already know the Pythagorean theorem. A squared plus b squared has to equal c squared. But in an acute triangle and an obtuse triangle, if you take the longest side, if the longer leg squared is less than the leg, sorry, they're not legs. If the longest side squared is less than the other two sides squared, the sum of the squares, then it's acute. Or if it is greater than the sum of the squares of the smaller sides, then it is obtuse. You can write it either way. This is how you usually see it written, but since we're used to writing a squared plus b squared equals c squared, I thought I'd write it both ways, and you can use whichever one you want. But it's all about c squared being either smaller than the sum of those two or larger. So this is the biggest one. That's 289. And then that's 49 plus 225. And that is, let me see, 50. What is that? Let's do it because my brain isn't working right now. So 274. So if a squared plus b squared is smaller than c squared, then what kind of triangle is that? So you can look up there in our little picture, and we say that this one goes here. This 289 is bigger. C squared was bigger than a squared plus b squared, so that's going to be obtuse. Okay. They have to be one of them. They're either acute, well, if they're actually a triangle. You got to watch out for that too, because we want to make sure that 15 is bigger than 12. Remember how the two smaller sides have to be larger than that third side. So be careful with that. I don't think I tricked you on this one, but sometimes it does get tricky, so you've got to be careful of that. So 25 plus 100 and 144. So that's 125 and 144. So again, c squared was bigger, so that's going to be obtuse. Okay, let's try this one. We have 100 and 100. Well, that's going to be an interesting one because we got two 100s, so there's not a longer one, but we'll just pick one of them. So obviously we know it's not right. So this squared is going to be 25 times 5, which is 125. So that is going to be an acute triangle because that one side was smaller than the sum of the other two, which is 225. All right. This one right here, this is the longer one, so that's the 16. And I'm going to square those. Remember that squared is 4 times 3, which is 12. So 12 plus 9 is 21. So the c squared, sorry, that's wrong. No, that actually was right, sorry. Oh my goodness, Mrs. Carter is making lots of mistakes. 21 is bigger than 16. Yikes! So when the c squared is smaller, then that's going to be acute. All right, so over here, I'm going to get my calculator out. 5.2 is the biggest, so 5.2 squared. So we got 2704. And then 1.7 squared plus 4.8 squared. I'm just going to do that all on my calculator. I got 25.93. 25.93. So c squared was bigger than this, so that means it's obtuse. And then let's try this one. It looks like that's the biggest. So 4 times 4 is 16 times 7. 16 times 7 is 112. And then 144, and then 256. So that's 256 equals 256. So this must be a right triangle since those are equal. Alrighty, so that is how you tell whether a triangle is acute, right, or obtuse. M squared, signing out.